I'm Bhavya, working as an assistant professor in computer science department at MIT Mysore. I welcome you all to analog and digital electronics lab session. So in this session, I'm going to explain to design a window comparator using a 741 opamp for any given UTP and LTP and to simulate the scene. So the aim of the experiment is to design and implement a window comparator for the given UTP and LTP. UTP and LTP are nothing but the upper threshold point and LTP is nothing but the lower threshold point. And the components required are opamp 741 and the resistor of 470 ohms and the diode having the specification of BY228 and one LED and regulated DC power supply. So here we are going to design a window comparator. So why we require this window comparator? What actually the window comparator is? Yes, a window comparator is a circuit that operates within a certain frame or within a certain window. Normally, how a voltage comparator works is when the voltage rises above the certain level at the inverting terminal, the output turns on. Any voltage above the reference level keeps the output on. So here in this window comparator, the given reference points are UTP and LTP. If that input voltage crosses this limit, then we should have some indication. For that indication, we are using this LED. So where actually this window comparator we are going to use is, so whenever we are going to design an industrial alarm, at that time we need this window uh, comparators. Then when we are going to design the level sensors and controllers, so at that time also we are going to use this window comparator and to control some digital computers and the production line testings. So there and all we can use this window comparator so that it can compare the input voltage and with the reference voltages. So these are the applications of window comparator, and we will see the circuit diagram of this window comparator. So for this we are using two op amps so of 741. So in this the first op amps inverting terminal is connected to UTP, that is the higher reference voltage or the upper threshold point. Then the non-inverting terminal of the second op-amp is connected to the lower reference voltage, that is your lower threshold point. Okay, the opposite terminals of both the op-amps are connected to the input voltage, and we have used the diodes for both the op-amps and one resistor for the circuit and this LED to take the indications whether the input voltage crosses the limit or not. So the Vin is when the Vin is lesser than the lower threshold point and the Vin is lesser than the upper threshold point. So here the diode is going to D1 is going to reverse bias and D2 is going to forward bias. Okay, so V0 will be what? So plus Vsat, and in case when the Vin is greater than VLT, when it is greater than VLT and Vin is greater than VUT. So when it is greater than VLT, the D1 is forward biased and D2 is reverse biased and the output is plus Vsat. So when the input voltage is lesser than your lower voltage and when the Vin is greater than your lower reference voltage and greater and lesser than your higher voltage, then it will be in the it will be within the range of the given reference voltages. Then the diodes are, then both the diodes are in reverse biased condition, then the output will be 0. 0 volts means it will give the indication like 0 using this resistor. Okay, so when it crosses the limits, when the input voltage crosses the limit, so this is going to forward bias, the old diodes will going to forward bias. Then when when this input voltage is within this range, then it is going to reverse, but then the diodes are going to reversed bias, then the output will be 0 volts. Okay, so at that time it will be in off region. So when it crosses the limits, it will be in on region. V naught will be plus V sat, that is it will gives 1. So high indicates that it is going to glow the LED. So the LED will be in on region. So when it is within the range, that is V input is within the range, means it is greater than your lower threshold value and lesser than your higher threshold voltage value, then the output will be 0, then the LED will be in 0 condition, that is in off region. So now we'll see how actually we are going to simulate this circuit using EWB software. So this software gives the menu and submenus. In the submenus, you can take the components what are all the requirement for your circuit design. So you just drag and drop on this window so that you can take those components and connect the circuit, then connect those components to make a circuit, and you can have a hands-on experience for the experiment. So how actually the circuit will works, you can see now. So what are all the components we require for this experiments? So we require two 741 opamp. So here you just click on it, so you can see the analog ICs. So here this, you just click on it, so it will give 5 terminal opamp, that is your 741 opamp. Then take another opamp, second opamp. Okay, so your minus terminal will be connected to the higher threshold point. Okay, so this is going to connect to a higher reference voltage terminal. So this, you take one battery, you just press on it and drag and drop on the window, then connect the terminals of the inverting terminal to the battery, then the other terminal of the battery will be connected to what, the ground. Then the opposite terminal of both the op amps are connected to each other, then these two will be connected to the input terminal. Then the non-inverting terminal of the second op-amp will be connected to a lower threshold point. The other terminal of the battery will be grounded of both input and the lower threshold point will be grounded. and you need to save the file as file name.ewb. So file name, I'll keep it as experiment3.ewb. Then plus will be connected to plus VCC and minus will be connected to minus VCC of the opamp. So for connecting the VCCs, we'll use the batteries. So plus will be connected to plus. You can rotate this by just click on it and rotate it. So plus will connect it to plus. Then negative will be connected to ground. And the output of this will be connected to one diode. So just to check whether it is forward biased or reverse biased. So these are the diodes you can take here. So just drag and drop from the submenus and connect the output of the first op-amp to the diode. And you need to set its specification to BY228. Okay. Then again, this plus VCC and minus VCC we need to connect. Take the battery. Then one more diode we require for the second op-amp. Of type BY228. Then connect the terminal of the second op-amp to the diode. Then we need one resistor, a pull-up resistor we require. So it works in an so how much we require? 470 ohm, not kilo ohm, that you need to set. So it will function as a AND gate. So if we use this resistor for the circuit, so there will be like outputs like zeros and ones, no? So for that it will work and output like a, it will function as a AND gate. Okay, so next we need required one LED So this represents the LED. So you just place a cursor on this, it will display the name of the component. Okay, so you just click on it, then drag and drop on this window. We just connect the output of the resistor to the LED. So just to indicate so whether the output is high or low. So if it is high means so it crosses the limit, if it is low means the input voltage is in its limit. Okay, then again you take one ground, so another terminal point will be grounded. Okay, like this. So this is actually the circuit diagram of your window comparator. Then so what is this? This is the input voltage, this is the higher reference, this is the lower reference. So now we need to set the values for this higher and lower reference voltages and the input voltage. So now I'll make the higher reference as 10 volts, then the lower reference voltage as 5 volts, and let it be the input voltage as 12 volts. See, the LED turns on because so your input voltage crosses the limits, means it is greater than your higher reference voltage. So then it is going to forward bias your diode. Okay, so it will gives the output as 0. Then the opamp, then the resistor will function as an AND gate. So it will go and make and turn the LED 1, means the high voltage will be 1 and it will turn on the LED. Okay, so when I'm going to set the input value as 6, see, the LED is off. So LED is in off condition. Why? Because the input voltage is within the range of 10 and 5 volts, means it is greater than your lower reference and lesser than your higher reference. Then both the diodes are in reverse biased condition and the output will be 0. Then it is going to turn off the it is going to turn off the 0 means in the AND gate 0 means wherever you take 0, so that will be the output will be 0 and the LED will turn off. Okay, so then again we'll check for 10.1. So higher we already checked, no? Yeah, we'll check for the lower voltage is 4. So now the input voltage is 4 volts. Now we will see the LED is turned on. Why? Because the input voltage crosses the limit, that is it is lesser than your lower threshold value, so that the bias will be turned on, your diode will be forward biased. Forward biased means V1 will be 1. So 1 means again the output will be like 1. So it is going to it will go and turn on the LED. So LED will glow because the input value crosses the limits, means it crosses the lower threshold value. So this is how we need to design the circuit of window comparator, and this is what the display we are checking with the LED. So based on the input voltage and the given reference voltages. Okay, then you need to save, you just save the file. You can pause the working procedure of the circuit. Okay, so this is how you can have an hands-on experience using EWB. So this is how you can simulate the experiment. Okay, thank you.